We're going to start again with the Aetherists. I was swamped this week with a bunch of Aetherists who came and bitched about my last video on ether. They didn't like it too much, you know, and here you'll see some of the problems that we find with the ether. And the main one is that they cannot illustrate the ether. There's not a single Aethirist on planet Earth, alive or dead, that has ever been able to illustrate the ether. They have no idea what they're talking about. And so here you have one fellow, and he says, "This is garbage channel." The fabric of space-time is the ether. It's always been there. It always will be there. Not going to watch your belief. Yeah, I guess once again, I think mind is a terrible thing to waste. And we have the Aetherists who are on ether, and then we have the Aetherists who are on crack. And what none of these folks can do is illustrate the ether. They cannot tell you what the ether is. They start already in the middle of the film, you know, saying, this is what I can do with the ether. No. First you got to show us the ether, then you can do whatever you want with it. Okay? And so that's the issue. And so this is what it comes down to. You know, they have no idea what the ether is. Some of them claim that they've never seen it, it's invisible, so that's why they have no idea what it is. But that's no excuse, because all you have to do, you know, when you're talking about the ether, is illustrate what you have in your mind. You know, just pull it out of your brain somehow and put it out here so that we can all see what it is that you are talking about. Okay, we need to understand first, if you're going to use it as an object, as a thing, if you're going to be moving it around, please begin by telling us what it is. And the way you explain what it is by making a picture. That's the only way. You put a picture and say, this is the ether. Point to it, we're done. That's how easy it is. Very simple stuff. And no excuses allowed. Okay, so here we have one Aethirist. He came over and he says, you have no objects without ether being perturbed first. So he's saying there are no atoms, no tables, no trees, no nothing, right? No molecules, unless you have perturbation of the ether first. And so what he's saying is that objects are made of ether. But ether, he says, is a perturbation, it's motion. And so all objects are essentially made of vibrations. That's more or less what he's got in mind. He's saying that ether is not a thing, but it's a potential. You know, something that I guess eventually will come to be, you know, and he calls that a perturbation. And not all etherists will agree with him. I'm just saying this is one fellow who says this is what the ether is to him, right? Now, doesn't mean that everybody will agree with him in the ether world, but this is what he's proposing, okay? And so he's saying that objects are made of potential perturbations or vibrations or whatever. It's just potential, right? I guess something that will eventually materialize. I guess that's what he's suggesting. Anyways, the problem there is that perturb is a verb. And, you know, nouns are not equal to verbs. Nouns are not verbs. So to say that a noun is made of motion, out of verbs, I don't know. I think he's overdone it on the ether. That's what I think, you know, he's done. And, this is the big problem. They have these weird notions. And they think they're scientists because they've discovered something. They say the ether is correct. It's this perturbation, this vibration of whatever. We don't have the object that's vibrating. All we have is verb without a noun. But he says the nouns are all made out of verbs. That's essentially what they're saying. And so, you know, for these fellows, we take them to the universal movie. What's a universal movie? It's a nice tool. It's a very handy tool for those who want to identify the objects in the universe. We stop the universe, right? We look at a single frame of the universe as if God took a snapshot at any given point in time. And that snapshot, which is, you can consider it a 3D snapshot, right? Shows every object in the universe, every atom, every molecule, everything that exists, right? And so we have now a snapshot of what's there. It fits all in a single frame of the film. And that's all the yellow stuff up there. All these concepts and every noun, everything in the universe fits into a single frame. You don't need to have two frames to know what a tree is, to illustrate a table or whatever. It doesn't matter. But when you look at a verb, you're looking at least two frames of the film. You can see the beige ones at the bottom there, the violet ones. And you can see that it occupies two frames, at least, of the film. Okay, that's what we're showing here. Nouns should be at the top, single frame, no need for two frames. The ones on the bottom, you need at least two frames. And so this fellow is saying that perturbation, that's what the verbs are at the bottom. You know, he's saying that you need to see an object in two frames because two frames make up one object. And no, I don't know what convent he went to or monastery, you know, but that's not true. Noun, we don't need to see any vibration. We don't need to see any motion whatsoever. In fact, nouns precede verbs. You know, objects precede motion. So, and, you know, one day I had a friend of mine who, chemist, by the way, and he was taught in college that, this is what he told me, it just shocked the hell out of me because I'm saying this is not true. But this is what he was taught. He said that objects are made out of motion. They're made of motion. And he just said it like, candidly, like it's a matter of fact. That's what he was taught and that's what he believed. And it just blew me away because this is completely irrational to say that a table is made out of motion. And people say, well, the electron moves, the atoms vibrate, molecules are all jingling. No. When God takes, with his big camera up there, takes a snapshot, I don't care about whether the electron in the lab moves. I know that in that picture that God just took, the electron had better be a static object. And that's what we're talking about here. We're saying, take a snapshot, what do you see? You know, and that should all fall in a single frame. We do not need two frames to know what a tree is, to know what an electron is, an atom, or whatever. Or ether. Okay, so here we have what this individual has in mind. He's got this ether world, some kind of vibration of whatever. We don't know what that is. Maybe a rug, you know, a piece of cloth. I don't know what that is, but that's more or less what they have in mind. And from this, he's going to build his particles, you know. One's going to pop out of there, right? And so they're saying that the particle is made out of motion, and we just want to know what it is the material that makes up, you know, the particle. Okay, and this is what they cannot tell you. They cannot say what that material that's shaking there is. They start with motion and build objects with it instead of the other way around. Using objects to say, okay, now I have two frames of the film. Now I build so-called motion with it. You know, objects build motion, not the other way around. Okay, so if we're going to do it rationally, that's the way you should do it. Objects. I mean, what is motion? Two or more locations of an object. So the object is here, then it's got a different location. Now you have motion. Period. What's location? Set of distances from one object to all the others in the universe. We're done. That's how simple it is. All you need is just good definitions, you know, scientific definitions, and then, you can give a rational presentation. Here's the 3D version of that, just in case. Okay, here we have the 3D ether. Okay, and we're going to put a particle in there. Okay, and there it is. It's moving around. This is what they have in mind. They're saying that the particle is essentially, you know, vibration of the ether. And again, that's how they try to elude the requirement that they illustrate the ether first. Now, I illustrated something there, right? And you say, well, you illustrated the ether. Well, no, I illustrated motion of some kind of, lines there. That's all I did. There's some line, we don't know what those lines are. You know, I mean, is that a net? Is that what it was, a fish net that was vibrating? So you got to identify the object first before you shake it. And all I can do is try to illustrate what these people are saying. But, you know, at the same time, I have no right to put these things in their mouths other than the fact that they haven't taken the trouble to illustrate what they have in their minds. But it's up to them. They're supposed to tell me what the ether is according to what they have in the top, on the top of their heads. Okay, so that's the way it works. Okay, and here we have another fellow, and he's talking about the ether, and he says, fine, Tesla was wrong about the ether. That's Nikola Tesla. I guess he was Yugoslavian or whatever Yugoslavia was in those days, the end of the 19th century. Anyways, he says, light doesn't require a medium to travel. So he's saying, here we have this thing that comes to your eye, right? And he says it doesn't require a medium. In other words, it's not mediated by any object. Light is, according to him, some kind of spirit. I guess it's a phantom, you know, an angel, I don't know. He's saying it doesn't need a medium. So whenever you shine a light, like from your laser to something to the wall, that red line that you can see, even sideways, because it really refracts through every atom of air or molecule of air in the environment, he's saying that that thing that you're seeing is not a thing. He's saying we don't need a medium. Okay, he says light travels fastest in the nearly perfect vacuum of space. That's not saying space doesn't have any properties. Well, I don't know what properties space can have. If space is nothing, space is not an object, doesn't have shape. So I'm not sure what properties he would assign to space. Invisibility, intangibility, maybe? I don't know. You could say those are properties. But other than that, I'm not sure what other properties he thinks space has. Certainly not those of objects. Space has very different properties, than objects, the opposites. That knowledge makes some really great practical applications. Well, that's talking about technology has nothing to do with science. Okay, science is about explaining. Technology is about making things. So whether it has practical applications or not is totally irrelevant. And then he says, this is the one that blows you away. The periodic table of elements is derived from the four classical elements: earth, water, fire, and air. This fellow's still stuck in the old Greek days. And he says, an akasha or akash, which means space or sky or ether in traditional Indian cosmology. And when you look up good old Tesla there, he says man's greatest achievement. And he wrote this, I think, 1907, sometime at the beginning of the century, 20th century. And he says, long ago, man recognized that all perceptible matter comes from a primary substance of a tenuity beyond conception and filling all space, the akasa, or luminiferous ether, which is cited upon by the life-giving prana. Again, I guess he read a lot of Indian stuff, or creative force, calling into existence in never-ending cycles all things and phenomena. And he says the primary substance thrown into infinitesimal worlds of prodigious velocity becomes gross matter. In other words, here we have this prana or whatever nonsense, akasa, and what it does is it underlies all matter. That's what he's saying. It's the verb that turns into a noun, right? The force subsiding, the motion ceases and matter disappears, reverting to the primary substance. In other words, here you have objects, things that disappear, that disintegrate back into this akasa or prana or whatever they want to call it, and which is the ether, and then the ether turns back into objects. So they have this thing going back and forth, but good old Nick, he never told us what the ether is. Everybody in those days used the ether as the mediator of light, so they did propose a mediator. Light was the vibration of the ether, but they never told us what the ether is. No one had any idea. Why? Because the ether was everything. It's like all these particles that fill space and they vibrate. And so they never defined it or never illustrated the word ether, right? And okay, so you have this thing out there and they say it's the vibration of the ether. But first you have to tell me what the ether is. You can't just jump ahead and say it's a vibration of the ether, because I still don't understand what you mean by the word ether. Okay, that's the issue. And so another fellow says, I can say the ether is real. Oh, okay, great. We finally have someone who can tell us that the ether is real. I have done several experiments. Okay, here we have a guy who does experiments on intangible, invisible things. Okay, and he's going to do a bunch of experiments. Okay, would be happy to send you the data. No, thank you. Don't send me the data. Send me the ether, in a little envelope, so I know what you're talking about. I've included a very simple explanation of how the ether forms and is sustainable. No, I don't want you to tell me how the ether forms. I want you to tell me what the ether is. Okay? If you can debunk what I show you, well, that's great. No, there's no need to debunking. All you need to do is very straightforward. You just send the ether, or illustrate it, or point to a website that has the ether illustrated so that we know what you're talking about. Okay? Yet I highly doubt that you can. My evidence is used to convince, to persuade, right? And that's why he wants to use evidence. He says, I'm going to persuade, I'm going to convince you. I don't want to be convinced. I want to understand. Okay? Supports the existence of God Almighty and heaven. So good old ether, I guess, is God, and God is ether. I have no idea what he's got in through his mind, this poor fellow. Yeah, all he's got to do, all these people have to do the same thing. Just illustrate the ether and we're done. Look how simple it is. All you have to do, all these years, Tesla and, Faraday, even all the way to Newton, all these people talked about the ether. No one ever illustrated the ether and told you what it is. And nobody ever realized that that's what you had to do. And they might say, well, I can't see it. I don't know. I've never seen it. I don't know what it looks like. Hey, this is what you have in your head. You have to pull out of your brain, out here, what you say or what you think the ether looks like. Okay? Because you're going to be using that word ether. You're going to be using this thingy. You have to tell the crowd what you have in the back of your mind. Bring it out here so we can all see it. We can all touch it. Bring it to the conference. Make a mock-up, and we can all touch the ether. Tell us what the ether is. Illustrate it. And they don't understand this. They say, well, I don't know what the ether looks like. I've never seen that. No, it's what you have in your head. That's what you got to put out here. We don't care what the ether is for real. We care about what you think the ether is so that we can follow your presentation. And so here it is, fellow. You have to define real also, right? And because we don't know what you mean by real, and that's a very important word in physics, because physics is the science of real, of existence, right? And in science, real means physical presence. That's what it means. If that's not what it means to you, then we require that you define the word real in the alternative. If ether is real, then you shouldn't have any problem to illustrate it according to that definition. Because physical is an object, and an object is that which has shape. Therefore, you have no reason to avoid not illustrating the ether. Okay? And experiments are not part of science, so don't worry about doing experiments. We don't care about experiments. We care about what you understood after doing your experiments. We care about your explanations. That's what you got to come forward with. And science has no use for evidence. Again, evidence is what is used to persuade, to convince, to convert. It's got to do with belief. You're trying to prove to a jury, and we call all that, we dismiss all that as religion. Okay, all that has to do with religion. It has nothing to do with science. Science we need to explain, not believe. And whether God exists is an assumption, So he says, my evidence supports the existence of God. You don't need evidence. You don't need to support anything. You need to define the word exist so that we know what you mean by the word exist, and then we'll know what you mean when you say that God exists or that heaven exists or whatever. And according to science, God exists means, it's an object with location. That's what you mean when you say God exists. If that's not what it means, what God exists means to you, no problem. You define the word exist for us, and then from there we'll find out if God exists by definition, right? Very simple stuff. Okay, here's another fellow, and he also insists on the ether. He says, Einstein came to the rescue and saved the Copernican model. All that was needed was to jettison the widely accepted theory of luminiferous ether. Since abandoning the Copernican system, prima facie, would be anathema, and abhorrence of the ether was adopted by the dominant faction and became the new orthodoxy. In other words, they displaced the ether, right? And they came with this stuff called space-time, which was preached with the greatest conviction and zeal by all correct thinking physicists, eventually, right, starting around 1920, leaving no room, no chairs, no grant money, no publication, no awards, and no respect according to wrong thinking non-believers. Okay, yeah, that's more or less what happened. Evidence of the heretical purging persists to this day and is legible in the sneering language found in all undergraduate physics texts on mechanics, and especially is seen in the presentations of science popularizers intended for laypersons, which invariably ooze with hubris, pride, and arrogance, as they pretend that science knows, and by inference, they know what science cannot know. Yeah, that's true. What they've done is harp on evidence, on proof, on belief. As for you parishioners, you're kneeling in the Church of Scientism and hearing a sermon from one of its priests. If you reject communion or refuse to repeat its creed, then you will suffer the fate of all non-believers. Yeah, first let's take care of Einstein here. He says, came to the rescue and saved the Copernican model by getting rid of the luminiferous ether. And here we have the record. Here is Einstein, at least two pieces of evidence, if he's talking about evidence. He wrote a pamphlet, a booklet there, and he says the following: Einstein ether theory is a modified theory of gravity that breaks Lorentz symmetry by introducing what? A dynamical vector field called the ether. And in 1920, in a talk that he gave at the University of Leiden, he says the following. Einstein said this. He says, we may say that according to the general theory of relativity, space is endowed with physical qualities. Just like this other fellow said a minute ago. He's saying it's physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable. So the good old Einstein, did he believe in the ether? Well, at least he did until 1920. Whether he changed his mind later on in life, I don't know. But he always talked about the ether and space-time, which is his bread and butter of the theory of general relativity, is an ether theory. He's saying, look, there's all these points in space-time, you know, all these dots out there. That's how Stephen Hawking defined it. What is an event? A point in space-time, and space-time is made of events, of points in space-time. So, yeah, we're talking about a whole bunch of dots out there, a bunch of particles, I guess. That's what they're referring to. We're talking about physics, and that was the theory. The theory is a particle theory. Okay, that is the ether, so nothing changed. The only thing that people sometimes debate is whether the ether is static or dynamic, whether it's moving or it's standing still. And objects such as the Earth are moving through a static field or through a dynamic field. That's the only issue. But the ether has always been a bunch of particles. Fluid, as they call it. What is a fluid? Made out of particles. I mean, that's what normal fluids are made of. If you think that a fluid is made out of something else, no problem. Illustrate it. Tell us what you mean by fluid. You know, you can't just say it's a fluid. Well, you haven't said anything. Okay? So far, you have a sandbox, static ether. You want to move it, that's something else. Okay? Before you move it, you got to illustrate the ether. Okay, some of that, and again, you can see these are all particle people. The fellow says the following: it's a misconception to assume that mass bends empty space-time and the path of a light ray. It's the gravitation from mass that changes the density of the medium through which the light propagation is happening. Okay? The direction of light is altered due to the varying density gradient of that medium. Okay? So perhaps that is what is near stars and around galaxies. Matter, not empty space. Okay? So he's saying that we have all this matter around every object celestial objects such as stars and planets and galaxy. We have all this matter running around, right? It's not empty space. There is no empty space according to him. In fact, if you look at astronomy literature, you will find that what? Hydrogen is all over the universe around galaxies and stars. No space-time required. So what this gentleman has in the back of his mind is that the entire universe is filled with hydrogen. Okay? So we have all these hydrogen atoms everywhere. That's the ether, right? Particles everywhere. And they're shaking, moving, whatever they're doing, we don't care. Sometimes they're static, sometimes they're moving. No problem. You can choose whichever you want. This is a complete misconception of what we have out there in the universe. This fellow doesn't understand how our universe is built. Certainly the universe is not made of all the, like, for example, between two galaxies, it's not filled with hydrogen atoms. He doesn't understand that. He thinks that hydrogen is everywhere between the galaxies, so instead of empty space, what you have is hydrogen atoms, meaning matter. And he says because the astronomers have found that around every galaxy, every sun, every star, every planet, what you have is hydrogen. And so he's saying because they found it around there, it's everywhere. But see, everywhere is not the same thing as around the star. You can find hydrogen around the star, yeah, but then at some point that dwindles and there is no more hydrogen at some point. To say that between any two stars you have, the whole field, the whole space filled with hydrogen, no, that's a total misconception. And here, let's educate this fellow a little bit so he doesn't commit that error again. These are the levels of vacuum, okay, that we have out there. We have atmospheric vacuum, vacuum or pressure here on Earth, right? And then you have values for each one. You have what is known low or roughing vacuum, which is a mechanical pump, can take it down to what is known as a micron or 10 to the minus 3 torr. And then you have the medium vacuum, takes it down to the minus 5 range, thereabouts. Then you have a high vacuum. I work with high vacuum. I worked at the minus 7 level. And then you have extreme high, ultra high vacuum, which is, in the 12, 13 range. And there you have two different sources that I put there. And one source puts, just looking at the low through ultra high vacuum, you see the powers there. You have the 22, 19, 16, and 12 under the one group, and the other fellow puts 19, 16, 13, 9, and 4. And you can see some of the numbers match. So more or less, this is what is out there in the vacuum world. You have these values, and you can see how the amount of particles per cubic centimeter or per cubic meter drops as you get to high vac. Okay, and that's the point that I'm trying to make here. So when you go out there between stars, you get into the minus 12 range, minus 11, minus 12 range. It's said that on the moon you have a minus 11 torr range. That's what was measured for those of you who believe that we went to the moon, right? And they measured it in space also on the trip to the moon. They had a device there, and they were able to measure as best as they could, with a moving rocket here, right, a probe, whatever. And they were able to measure the vacuum of space, and from that they inferred or measured, right, as closely as possible, that the solar wind, they talk about solar wind, everybody thinks it's a wind like, air here on Earth. No, it ain't. It's minus 12 torr. It's even less dense than on the moon, an order less dense. And so that's the vacuum out there. You either have minus 11, minus 12, and what you're talking about, very few particles per centimeter cube. And unless you understand that, you're going to make errors like the electric universe makes, that they have this connection from star to star, and they say electricity flows from star to star. Absolutely not. It's impossible. It's impossible because there is no matter in between two stars. You have high vacuum, you have one particle over here, the other one separated. How does, from this particle, how does electricity flow to that particle? If the flow of particles is the movement of an electron from atom to atom. Now you can do that in a vacuum chamber as long as you have first high vacuum and then introduce, say, an inert gas such as argon, right? Then now you filled the chamber back with atoms, with molecules. Now you can have electricity. But if you take all the stuff out, if you get to -7 range like we used to work with, sometimes you get arcing, which is, a glitch, but you cannot have a constant current on -7 range. And out there you have -11, -12, forget it. You're never going to get electricity, as the electric universe, tells the crowds. They say that some of the features in Mars were made by electric shocks, thunderbolts. No way, it's impossible. There's not enough matter around Mars to create a thunderbolt. Okay? You don't have thunderbolts on Mars because there is no matter to do electricity with. You need matter, atoms, molecules, to have electricity. And these people don't understand that. They think they can do electricity just by flowing beads, electron beads, from one atom over there to one atom over there. No way, you can't do that. These people don't know the basics of vacuum and of electricity. That's the whole issue. Okay, here's a fellow who talked about the Harvard Tower experiment. He said, GPS sends a modulated signal from satellite to ground. The time at which it reaches the ground can be measured, okay? Time received is multiplied by the speed of light to get the distance, okay? If the frequency or energy increased in transit during that time, the phase reversals would be wrong and the major distance would be short, okay? And he says the frequency cannot be changing as it falls. Did you actually, the first part up to there was a quote that he quoted someone. Now he comes in here and he says, did you actually conflate distance for length when talking about a rope? Yes, you did. Okay, I have no idea what he's talking about, okay, because I wasn't talking about distance or length, okay? It had nothing to do with this at all. And so I want to clarify what I was saying, at least. I don't care what he understood, but I'm going to say what I really mean, what my theory is, what I'm proposing, okay? And I'm saying that as the ropes come out of the earth, okay, they tend to get longer. By longer, it doesn't mean that, very long. It means that, if you got a high frequency rope, meaning very short links and many links, as that goes outwards, right, eventually the links get longer and you have fewer links. That's all I'm saying. We don't care about the amounts because we don't care about amounts. All we're saying is it does tend to get in that direction. And here, let me show you here. Here you have light coming out of the earth, and the earth goes in every direction. The question is, what is that light, those rays that are coming out, what is that mediated by? Okay, that's the issue. And so we simulate it with ropes. Here it is. Okay, so we're saying that what we have is torsions along each one of those ropes, and torsion travels in both directions. Okay, so we have ropes. We're saying that light is mediated by a rope-like entity. So there is a mediator for light, and we're saying it looks more or less like that, like a pair of twined threads, like DNA. That's what it is. Okay, and so the issue is the following: when you have a satellite out there, like GPS or whatever, okay, some of the ropes end up in the atoms that make up the satellite. Okay, and some of them continue because they don't stop at that atom. Some of them belong to atoms that are on the moon and another star, another galaxy. So you have all these ropes, and most of them are superimposed. They're on the same axis. Okay, and so you have to understand that, because if you take a cross section, like if you're going to measure frequency, meaning you're going to measure a cross section somewhere along an axis, you're going to have many gazillions of ropes on that same axis. And that means some of them are going to have short links and some of them are going to have longer links. In other words, you're going to have different frequencies and different wavelengths for any cross section, because every atom in the universe is connected to every other atom in the universe. Okay, so we have to understand that on a given axis, we're not going to get a single rope. We're going to get gazillions of ropes. They're all going to have different frequencies. Okay, so that's, you have to put that in the back of your mind, because that's important. Okay, so whenever they take a reading, cross-sectional reading, at any point and say, what's the frequency here? The frequency is so much. Okay, we don't care, because what they're doing is taking a reading, a cross-section of many, many, many ropes that pass through that point. You can't take a measurement of one rope between only two atoms. Okay, no matter what. When you have two atoms, you have gazillions of ropes going through those two atoms. Only one rope connects this atom to that atom, right? But there are many ropes crisscrossing the entire universe. They're going right through there. Okay, so that's important to understand. So what happens? Let's say you have a flashlight, okay, and you're going to point it at a wall. Okay, so you have this flashlight, and you can see that there are atoms that are originating in the bulb of the flashlight, and they end at the wall. Okay, so you have some atom, many atoms there, right, that just are connected from the atom in the flashlight to an atom on a brick on a wall, for example, right? But as you can see, there are other atoms that are coming from behind the flashlight, going right through the flashlight, right through the wall, and going to other atoms in the universe. Okay? We cannot isolate a single one of those ropes and say, I'm going to read what the frequency is on one rope only. What you're always going to get is an average, right? But the main one will be the one that's closest to your scenario. Okay, so as soon as you turn the flashlight on, okay, and you point it at the wall, you get this situation where suddenly, you know, the high frequency that you suddenly put in your region, that takes precedence. Okay, so you can more or less get a reading of your frequency there, but again, you're reading many ropes. You're reading the torsion on many ropes, you're reading the wavelength on many ropes, the link length, right? But you still have all these other atoms that are connected from behind the flashlight, right through the flashlight, to atoms on the wall and beyond. So you have all these things going in that same region. And what you're going to be doing, whether you like it or not, is taking an average of that. Okay, and so for this fellow to be so sure that he measured a given frequency, well, you know, he's got to factor this scenario in mind. Okay, and that's all I can tell him. You cannot really say for sure what the frequency is, because you cannot measure the frequency, wavelength, you know, link length of just one rope from one atom to another. We don't have that capability yet. Okay, we're too far away from that. Okay, another fellow says something about the Harvard Tower experiment, and here it is. The pound replica experiments were done at Jefferson Labs. Okay, the elevation on the ground is 3 meters above sea level. The temperature would be 14 degrees. Okay, the gamma rays traveled through a mylar bag filled with helium. Okay, so he's saying it wasn't completely isolated. You know, they had something there. Okay, which is a refractive medium, meaning that we're going to disperse that beam. That's more or less what he's saying here. To minimize scattering of the gamma rays, but you're still going to have some scattering, right? Poundrek found that a large source of systematic error resulted from temperature variations due to lattice vibrations. Okay, so we have all these interference or these obstacles or these influences in our experiment, right? A mere 1 degree difference in temperature between emitter and observer caused a shift about equal to the predicted effect of gravitational time dilation. Okay, I'm not going to criticize what he said. He's got a good point there. Okay, not that I agree with it, but he's got a good point. Okay, the question is, how isolated was the experiment when they did it? But more important than that, you know, the mathematicians, they pride themselves in talking about repeatability, and no one has ever, I looked it up, I can't find it. I mean, if you can find it, please send it to me, but I can't find that anyone has ever repeated the Harvard Tower experiment anywhere on the planet. It doesn't have to be the exact Harvard Tower. You know, you don't have to go to Harvard to do it. You can do it anywhere. And once you have the setup, you say, okay, I'm going to repeat the setup, see if I get the same result. And I can't find anyone who repeated that specific experiment. You know, one on the bottom, the other guy on the top, and sending a beam in both directions, first from the top down and from the next from the bottom up. And so I have not seen a repeat of the Harvard Tower experiment. It's like everybody just accepted it and said, okay, it's blessed. So just keep that in mind as well, and that's my only criticism there. One fellow says, I guess he confused atheists with aetherists, but still we'll address what he said. Atheists don't propose any theory. So I don't know if he put that under the ether video. But so let's address atheism just in case, so we don't put words in his mouth. Atheism is the religion of mathematical, theoretical physicists. Okay, that's what it is. Atheism is incorrect science. It's irrational science. That's what atheism is. Why? Because they talk about belief. And what do atheists propose? Well, they propose the same thing as all mathematical physicists or theoretical physicists. They propose what quantum mechanics, special and general relativity and string theory propose, and that is that you have to prove, that you have to believe, you have to present evidence and have knowledge. And none of that has to do with science. In science, we do not have knowledge, we do not use evidence, we do not propose to or purport to influence people's way of thinking other than through understanding, you know, explanation. I explain, you understand, we're done with physics or science. But if you now introduce evidence to try to convince someone, now you're persuading, now you're doing religion. And we have to separate those two. So all these Bible thumpers of general relativity and quantum mechanics, they're not doing science. What they're doing is persuading. That's religion. And being that the case, you know, they haven't done anything different than religion has done all these centuries. And here, let me synthesize that for you in a little video. And here it goes. Just watch it. Okay, here it goes. What is a theist? A guy who believes in that God exists. What is an atheist? Well, it's someone who doesn't believe or disbelieves, or however they want to word it, that God does not exist. Okay, an agnostic is a guy who doesn't know whether God exists or not. And we take all of these fellows and put them in the trash can. They're all under religion. This is all religion. And that's why all these people, you know, they haven't been able to figure out anything in science, because they're using evidence and that kind of thing. They're talking about belief. And here, this is what rational explanations are all about. It's objective, it's explanations. That's what science is about. Okay? So, make sure you are not a mathematical physicist, because if you are a religious individual. Your religion is atheism, and atheism is founded on belief. They call it disbelief, they call it not believe, unbelieve. They use all these terms, and they run around in circles. Atheism has to do with belief only. Belief in God or disbelief in God, or whatever you want to call it. And the issue there is very simple. We do not do belief in science. So all these people are doing religion. And they've been running around in circles, chasing their tails around, arguing in circles for centuries. Okay, final issue of fellow says, a thoughtful, contrived, systematically executed, extremely well-funded, and relentlessly persistent campaign of denigration, mockery, fear-mongering, and false reporting of assemblages of anecdotal evidence directed against the established, now deemed alternative systems was implemented. He's saying that when the mathematicians at the beginning or first quarter of the 20th century came with space-time and quantum mechanics, they brushed aside everything from classical mechanics, essentially. And the situation is not unlike that of relatively new orthodoxy or allopathy. The business of science prevails over science itself. He's saying there's a lot of hullabaloo. They tend to say that they've discovered something that it's new. They have this new theory. It's a paradigm shift, et cetera, and he's saying it's all business, really, ultimately. And so what do I have to say about that? Well, I'm certainly one person who has a little bit of experience with that. When I came to some of these websites, or really forums, where you had all these college guys, and I started telling them, hey, guys, I went in there like mild-mannered Clark Kent, I thought I was very naive and with respect to all these people. And I said, look, I have a new theory. I want to share it with you, blah, blah, blah. Boy, did I get a lot of rotten eggs thrown in my face. I couldn't believe the environment out there. I thought science was, normal or just an exchange of ideas, and that's not the way it works. They use a lot of ridicule. They do censorship, and yes, it is a business, and people are concerned about their careers, and so I don't think that's avoidable. That you cannot. I don't think you can avoid that. And here we have a good example. This was thrown at me once, and so I always like to put this up there, and that's from Juanito Baez, fellow that is in California, and he thinks of himself as a big shot. He's the guy who created the crackpot index. They used this against me in a couple of those forums, and that's how I found out about it. And here you have some example. He says 10 points for each claim that quantum mechanics is fundamentally misguided. 10 points for arguing that while current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. Absolutely. And so he just says you get 10 points off for requesting, for demanding an explanation, a mechanism, a why. And he says, hey, you get 10 points off for just asking. In other words, he's not going to give you a why. He's not going to give you an explanation, a mechanism. He has no clue whatsoever. Why? Because he's a mathematician. That's all he is. And then he says 10 points for each claim that special or general relativity are fundamentally misguided. And again, I think if I were the U.S. government, I would deport Juanito back to Mexico, where his mamacita came from, where she was picking strawberries or beans out there in the fields. Yeah, this does not understand what science is about, and that's why they use ridicule. And so I don't feel bad when I ridicule them. Actually, I don't ridicule them. I treat them with the respect that they deserve. That's the way I put it. But it doesn't stop with the mathematicians of today. Here, let me show you something else. These were the different schools of thought, right? Let me make this better this way. These were different schools of thought from the Greeks, right? And what I want you to understand about this is they came from different cities and they formed in different towns, etc. And all these different schools would ridicule the other schools. Like, look what this guy believes in. They would ridicule one another. And so ridicule has been with man since day one, okay, in so-called science. And so I was very naive when I came out. I thought, that there was a peaceful environment there where you can present your theories and so on. That's not the case. So anyone who goes in there and starts getting all excited because someone insulted them or ridiculed them or censored them should come up to speed, that the environment has always been a so-called scientific or exchange of ideas environment, has always been cutthroat. It's a dog-eat-dog world, out there. And so for people to expect that a guy who you're challenging, his ideas, his God, his Jesus Christ, his space-time, whatever you're challenging, you better be ready to receive a handful, of rotten tomatoes in your face. Okay, and there's no way to avoid it. That's always been the environment. He who has not understood that, oh man, he's a babe in the woods. He's a little lamb, and the environment out there is very nasty. Be ready for it. They will not allow you to publish, censorship. They will ridicule you if you go to a forum, and they will insult you and they will do everything they can. So just be ready. That's the environment. That's the scientific environment. It's always been like that.